Imagine looking up at the night sky, seeing the vast tapestry of stars, galaxies, and cosmic mysteries stretching endlessly. Now ask yourself, what if the universe isn't just a collection of inert matter and energy? What if the entire cosmos, every particle, wave, and field, is part of a vast, interconnected consciousness? What if the universe itself is a thinking entity? This is not just a whimsical question, it's an idea that challenges the boundaries of science, philosophy, and our deepest assumptions about reality. Could the universe know of its own existence? Could it have purpose or intent? Could it, in some profound way, be aware of you? For centuries, humanity has grappled with the nature of consciousness, searching for answers in philosophy, religion, and science. From the musings of ancient thinkers to modern neuroscience and quantum physics, we've sought to understand the essence of what it means to think and be aware. While we've made strides in understanding human consciousness, the question of whether consciousness extends beyond the human mind, or even beyond biological systems, remains open. Enter the universe. At first glance, it seems like a cold, indifferent expanse, governed by immutable laws of physics. But as we dive deeper into its mysteries, patterns begin to emerge. The self-organizing behavior of galaxies, the intricate interplay of particles, and the pervasive role of information in shaping reality. Could these patterns hint at something deeper, a kind of universal mind? This question sits at the crossroads of multiple disciplines. Physics provides the laws that govern the universe's behavior, from the smallest quantum particles to the largest galactic structures. Philosophy asks what it means for something to be conscious or to think. And consciousness studies challenges to understand how subjective experience arises from matter, or whether it might exist fundamentally in the fabric of the universe itself. In this video, we're embarking on a bold and profound journey. Our mission is to explore the idea that the universe is not only conscious but actively thinking. We'll delve into cutting-edge scientific theories, from quantum mechanics and information theory to cosmology and the nature of complexity. We'll also draw on philosophical insights, asking what it would mean for the universe to possess a kind of awareness. This isn't just about idle speculation. We'll examine the evidence, question the assumptions, and push the boundaries of what we think is possible. By the end of this journey, you'll see that the idea of a thinking universe is not just a poetic notion, it's a hypothesis grounded in some of the most profound insights of modern science. So, buckle up and prepare to explore a universe that might just be alive, thinking, and, perhaps, aware of you. Defining consciousness. Consciousness in humans. Consciousness is one of the most mysterious and profound aspects of existence. It's what allows us to experience the world, think about our place within it, and even question what consciousness is in the first place. But what exactly is consciousness? Let's break it down into its defining characteristics. At the core of consciousness is the ability to be aware of oneself. Humans can reflect on their thoughts, emotions, and actions. This self-awareness enables us to understand that we exist as individuals distinct from our surroundings and other beings. For instance, when you look in a mirror, you don't just see a face, you recognize yourself. Consciousness is also characterized by intentionality, the ability of the mind to direct itself towards something. This doesn't mean intention in the sense of planning, but rather the way our thoughts are always about something, whether it's a memory, a goal, or an abstract concept like justice. This directedness of thought is a hallmark of human cognition. Perhaps the most perplexing aspect of consciousness is qualia, the subjective, first-person experiences that make up our mental lives. Qualia include things like the redness of a sunset, the bitterness of coffee, or the pain of a stubbed toe. These experiences are deeply personal and cannot be fully conveyed through language or measurement. Despite these characteristics, defining consciousness remains an enormous challenge. The problem isn't just philosophical, it's scientific. Neuroscientists can map brain activity and identify areas linked to certain experiences, but this doesn't explain how or why those patterns produce subjective experiences. This gap between the physical processes of the brain and the lived experience of consciousness is often called the hard problem of consciousness, a term coined by philosopher David Chalmers. Unlike the easy problems of neuroscience, which involve understanding how the brain processes information, the hard problem asks why these processes give rise to a conscious mind at all. This question remains unresolved, and it's what makes consciousness one of the most fascinating mysteries in science. Consciousness in the universe. If consciousness is so mysterious in humans, can we even begin to ask whether the universe itself might possess consciousness? Surprisingly, some scientists and philosophers argue that we can. This brings us to the concept of panpsychism, a theory that reframes consciousness as a fundamental feature of the universe. What is panpsychism? Panpsychism proposes that consciousness isn't unique to humans, or even to complex organisms, but is instead an intrinsic property of all matter. In this view, even the smallest particles, like electrons or quarks, might have some rudimentary form of consciousness. These individual, proto-conscious, elements could combine in complex ways to create the rich, self-aware consciousness we see in humans. For example, consider a rock. Panpsychism doesn't suggest that the rock is thinking in the way you or I do. Instead, it posits that the particles making up the rock might each possess an unimaginably basic form of experience. Over time and under certain conditions, such as in living organisms, these micro-level experiences could aggregate into the full-fledged consciousness we recognize. This idea gains traction when we consider that consciousness might be tied to the fundamental fabric of the universe. Just as mass, charge, and spin are basic properties of particles, consciousness could be another intrinsic quality. This would mean that consciousness is as natural and universal as gravity or electromagnetism, woven into the very structure of reality. Panpsychism offers an intriguing solution to the hard problem of consciousness. If consciousness is fundamental, there's no need to explain how it arises from non-conscious matter, it was always there. This view challenges the traditional materialist perspective, which assumes that consciousness must somehow emerge from the physical interactions of matter. Instead, panpsychism suggests that consciousness is a built-in feature of the universe, just waiting to be revealed in certain configurations. Philosophical and scientific implications. Philosophically, panpsychism bridges the gap between the subjective and the objective. It suggests that the division between mind and matter is an illusion and that the universe is a seamless whole with consciousness as a key aspect. Scientifically, it opens new possibilities for studying consciousness by encouraging researchers to look for its traces in unexpected places, such as the behavior of particles or the structure of spacetime itself. Connecting the two. Human consciousness is undoubtedly complex, but the principles of self-awareness, intentionality, and qualia may not be exclusive to us. Panpsychism invites us to imagine a universe where these characteristics exist at every level of reality, from atoms to galaxies. If true, this means that the universe doesn't just exist, it experiences. The idea of a conscious universe is bold, but it forces us to question our assumptions about what consciousness is and where it might reside. Could our subjective experience be just one small part of a vast, interconnected web of universal awareness? In the next section, we'll examine how the Big Bang, the event that birthed the universe, might have also set the stage for a cosmic mind to emerge. The Big Bang and the Emergence of Complexity. The Big Bang, the universe's beginning. Around 13.8 billion years ago, the universe as we know it began with the Big Bang, a moment of unimaginable density and heat where space, time, matter, and energy all emerged from a singularity. The term, Big Bang, can be misleading. It wasn't an explosion in the traditional sense but an expansion of space itself, carrying with it the seeds of everything that would ever exist. The initial conditions. In the first fractions of a second, the universe was a hot, dense plasma of energy, with temperatures exceeding trillions of degrees. During this period, fundamental particles like quarks, leptons, and gluons were formed. These particles interacted in an environment governed by what we now understand as the four fundamental forces: gravity, governing the attraction between masses; electromagnetism, controlling interactions between charged particles; the weak nuclear force, facilitating certain types of particle decay; the strong nuclear force, binding quarks together to form protons and neutrons. These forces and the particles themselves are described by the laws of physics, which seem to have been established in the immediate aftermath of the Big Bang. The creation of these laws was a pivotal moment. They provided the framework for everything that followed. As the universe expanded and cooled, particles began to combine. Quarks formed protons and neutrons, which eventually bonded to create the first atomic nuclei during a process called nucleosynthesis. A few 100,000 years later, electrons joined these nuclei to form neutral atoms, primarily hydrogen and helium. This period, known as the recombination era, allowed light to travel freely, creating the cosmic microwave background radiation we observe today, a faint echo of the Big Bang. Over time, tiny fluctuations in the density of matter, observed in the cosmic microwave background, were amplified by gravity. Denser regions attracted more matter, leading to the formation of stars, galaxies, and clusters of galaxies. These structures provided the scaffolding for the universe as we see it now, with its intricate web of filaments and voids. Emergence of complexity. From the simplicity of quarks and electrons, the universe evolved into a system of breathtaking complexity. This journey showcases the principle of emergence, where simple interactions give rise to complex behaviors and systems. The first stars ignited as gravity-compressed clouds of hydrogen and helium. Within these stars, nuclear fusion began, creating heavier elements like carbon, oxygen, and iron. When massive stars ended their lives in supernova explosions, these elements were scattered across space, enriching the cosmos with the building blocks of planets and life. As heavier elements became more abundant, they combined to form molecules. These molecules, under the right conditions, could form complex organic compounds, precursors to life. Planets like Earth, rich in these compounds, became cradles for even greater complexity. On Earth, simple organic molecules organized into self-replicating structures, leading to the first forms of life. Over billions of years, evolution through natural selection drove the development of more complex organisms. From single-celled bacteria to multicellular life forms, each step added layers of complexity and interaction. Eventually, some life forms, like humans, developed consciousness, a leap in complexity where matter began to experience and understand itself. This represents one of the most profound examples of emergence, from the chaotic simplicity of the early universe to self-aware beings capable of pondering their origins. The concept of emergence. Emergence refers to the process by which larger patterns, systems, or phenomena arise from the interactions of simpler components. It's a hallmark of complex systems and can be observed in physics, galaxies forming from gravitational interactions among stars; biology, cells working together to create living organisms; neuroscience, neurons interacting to produce thoughts and consciousness; Emergence demonstrates that complexity isn't just a matter of adding more components, it's about the relationships and interactions between them. Importantly, emergent systems often exhibit properties that cannot be predicted or explained by their individual components alone. For example, the wetness of water is an emergent property of HO molecules, which individually are not wet. In the context of the universe, this principle raises profound questions. If simple particles and forces could give rise to galaxies, stars, and life, could the universe as a whole be an emergent system capable of consciousness? Could the interplay of matter, energy, and information on a cosmic scale produce something akin to a universal mind? Connecting to the big picture. The Big Bang set the stage for the universe's journey from simplicity to complexity. Over billions of years, particles combined, systems self-organized, and complexity emerged in countless forms, including life and consciousness. This trajectory suggests that the universe is not static or inert but a dynamic, evolving system. Could this progression be evidence of a deeper principle at work, a principle that might culminate in the universe itself being conscious? In the next section, we'll delve into how information, a key driver of complexity, plays a crucial role in this unfolding story. Information theory and the universe. Information is a fundamental quantity. In physics and cosmology, information is increasingly recognized as a fundamental building block of reality. Just as matter and energy are essential components of the universe, so too is information, the arrangement, transmission, and transformation of data that defines the state of a system. This concept bridges the physical world and the abstract, offering a lens through which we can understand the underlying structure of the universe. What is information in physics? In simple terms, information in physics refers to the data needed to describe the state of a system. For example, the position and velocity of a particle, the configuration of a molecule, the quantum state of an electron. Claude Shannon, the father of information theory, quantified information as the reduction of uncertainty, how much we learn when a system transitions from one state to another. In this sense, information isn't just a theoretical abstraction, it's a measurable and calculable property of physical systems. Information in the universe. The universe is an intricate information processing system. Consider these parallels. Human brain. Neurons in the brain transmit electrical signals, encoding and processing information to produce thoughts, memories, and actions. Cosmic systems, stars, galaxies, and black holes interact in ways that encode and exchange information. For example, the cosmic microwave background radiation is a vast repository of information about the early universe. Black holes store information on their event horizons, a concept we'll explore further with the holographic principle. This comparison between the brain and the cosmos highlights an intriguing possibility. Just as the brain processes information to create consciousness, could the universe process information on a grand scale, leading to a form of cosmic awareness? Information is deeply connected to entropy, a measure of disorder in a system. In thermodynamics, entropy increases as systems move toward equilibrium, dispersing energy and reducing order. However, in this apparent chaos, information is not lost, it's transformed. This principle underlies the famous statement by physicist John Archibald Wheeler, "It from bit," suggesting that every particle, field, and force in the universe arises from fundamental units of information. The holographic principle. The holographic principle is one of the most fascinating ideas in theoretical physics, offering a radically different perspective on the nature of reality. It suggests that the universe, in its entirety, can be understood as a two-dimensional information structure encoded on a cosmological horizon, with the three-dimensional world we experience emerging from this encoded data. What is the holographic principle? The holographic principle originated from studies of black holes. In the 1970s, physicist Jacob Bekenstein proposed that the information contained within a black hole is proportional not to its volume, but to the surface area of its event horizon. This idea was later expanded by Stephen Hawking and Leonard Susskind to apply to the entire universe. The principle posits that all the information needed to describe the universe is stored on a two-dimensional boundary, a kind of cosmic hologram. Just as a flat holographic film can create the illusion of a three-dimensional image, this two-dimensional information gives rise to the three-dimensional universe we inhabit. Evidence and implications. Black hole thermodynamics. The connection between information, entropy, and the surface area of black holes provides strong theoretical support for the holographic principle. String theory. The holographic principle aligns with string theory, which describes particles as one-dimensional, strings, vibrating in higher dimensional space. ADS, CFT correspondence. A mathematical realization of the holographic principle, this correspondence shows that a quantum theory in a lower dimensional space can describe gravity in a higher dimensional space. If the holographic principle is correct, then what does this mean for the universe? The universe is fundamentally an information processing system, with every particle and field representing encoded data. Space and time themselves may emerge from this underlying information, making them not fundamental, but emergent properties. Consciousness could also be an emergent phenomenon of this cosmic information processing, suggesting that the universe thinks in ways analogous to, but far more expansive than, the human mind. Connecting information to consciousness. The parallels between the brain's information processing and the universe's structure are striking. The brain uses neural networks to encode and transmit information, giving rise to thought and awareness. Similarly, the universe's cosmic web, a vast network of galaxies connected by dark matter filaments, could serve as a framework for processing information on a cosmic scale. If information is fundamental and pervasive throughout the universe, it raises profound questions. Could the universe's information processing capabilities lead to a form of awareness? If so, would this consciousness operate on timescales and dimensions utterly alien to human experience? Is it possible that we, as parts of this universe, are contributing to its broader, thought processes? In the next section, we'll dive into quantum mechanics, exploring how phenomena like entanglement and non-locality further challenge our understanding of information, locality, and consciousness. Could quantum physics hold the key to a thinking universe? Quantum mechanics and consciousness. Quantum entanglement, challenging locality. What is quantum entanglement? Quantum entanglement is a phenomenon where two or more particles become so deeply connected that the state of one particle is instantly correlated with the state of the other, no matter how far apart they are. This correlation persists even if the particles are separated by vast distances, challenging our classical understanding of how information and causality work. For example, if two entangled particles are created, measuring the spin of one particle instantly determines the spin of the other, even if the particles are on opposite sides of the galaxy. This spooky action at a distance, as Albert Einstein famously called it, seems to violate the classical principle of locality, the idea that objects can only be influenced by their immediate surroundings. Entanglement arises from the mathematical structure of quantum mechanics. When particles interact in specific ways, their quantum states become intertwined, forming a shared wave function. Even after they separate, the wave function remains unified, so any measurement of one particle directly affects the state of the other. Implications for the universe. Entanglement reveals that the universe is fundamentally non-local, with connections that transcend space and time. It challenges the classical view of an independent, isolated universe, suggesting that everything is interconnected at a quantum level. Consciousness and entanglement. Some theories propose that consciousness could be related to quantum entanglement. For instance, the brain might operate as a quantum system, using entanglement to process information more efficiently than classical systems. Consciousness might emerge from the non-local connections between quantum states, creating a unified experience from disparate neural activities. While speculative, these ideas point to the possibility that consciousness could be a fundamental property of the universe, rooted in the same principles that govern quantum mechanics. Quantum theories of consciousness. Building on the idea that quantum mechanics underpins the physical universe, several hypotheses suggest that quantum processes could also play a role in generating consciousness. One of the most well-known theories is orchestrated objective reduction, OR. Developed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, OR proposes that consciousness arises from quantum processes occurring within the microtubules of neurons. What is the OR theory? Microtubules. These are tiny, tubular structures in cells that help maintain their shape and play a role in cellular functions. In OR, microtubules are suggested to act as quantum processes, capable of sustaining quantum states for brief moments. Objective reduction. According to this theory, quantum states collapse in a process tied to gravity, producing conscious experience. The orchestrated part refers to how this process is guided by the brain's biological functions. Traditional neuroscience views consciousness as an emergent property of classical neural networks. However, Penrose and Hameroff argue that classical physics cannot fully explain the richness of conscious experience or phenomena like free will and creativity. Why quantum mechanics? The brain might operate as a quantum system, using entanglement to process information more efficiently than classical systems. Quantum coherence in microtubules could enable the brain to process information in a fundamentally different way, integrating vast amounts of data into a unified conscious experience. Criticisms and challenges. Skepticism. Many scientists are skeptical of OR, citing a lack of empirical evidence and the difficulty of maintaining quantum coherence in the warm, wet environment of the brain. Experimental validation. Recent studies have explored quantum effects in biological systems, such as photosynthesis and bird navigation, suggesting that quantum phenomena might be more common in living organisms than previously thought. This lends some plausibility to OR and similar theories. Beyond OR, other theories propose links between consciousness and quantum mechanics. Other quantum theories of consciousness. Quantum brain dynamics suggests that quantum fields in the brain interact with neural structures to create consciousness. Holonomic brain theory proposes that the brain processes information in a manner analogous to holography, with quantum mechanics playing a key role. The universe as a quantum consciousness. If consciousness is fundamentally tied to quantum processes, and quantum mechanics operates universally, could the universe itself exhibit consciousness? The interconnectedness revealed by entanglement suggests that the cosmos might function as a vast quantum system, with its thoughts arising from the interactions of its components. In quantum mechanics, the universe can be described as a single wave function encompassing all matter and energy. This wave function evolves according to the Schrödinger equation, and its entangled components suggest a deep, intrinsic connectedness. Cosmic scale consciousness. If consciousness emerges from quantum processes, it's conceivable that the universe, with its vast complexity and interconnectedness, could have its own form of awareness. This cosmic consciousness wouldn't resemble human thought but might operate on timescales and dimensions far beyond our comprehension. Connecting the dots. Quantum mechanics challenges our classical assumptions about reality, revealing a universe that is deeply interconnected and fundamentally strange. Theories like OR hint that consciousness might arise from quantum processes, suggesting a possible link between the mind and the fabric of the cosmos. In the next section, we'll explore how the universe's structure, its vast networks and patterns, parallels the complexity of the human brain, further reinforcing the idea that the universe could be a conscious entity. Stay tuned.